So before we actually get into lab, I wanted to make sure to give you all an opportunity to be able to see what types of glassware we're going to be looking at as we work through the lab this semester. So I'm just going to go through some of the things that are in the lab drawers that I have here at the high school that are very similar that you're going to find at the University of Cincinnati lab station. So first over here, what we're going to look at are beakers. And beakers are just our main utensils where we mix particular materials in. There's really nothing special about them. They come in a variety of different sizes and shapes. The smallest ones that I have here are small 50 milliliter beakers, but we also have ones that are 100, 250, 400, 600, and 1000. So lots of different beakers for a variety of different things. If we're mixing large amounts of material, we're going to be using larger beakers versus smaller amounts of material where we would use the smaller beakers that you might find. In addition to that, over here we have what are called Erlenmeyer flasks. And you notice that they look a little bit different. They do hold volume just like the other material or the other beakers do, but in this case they have kind of a smaller neck per se. We probably won't be using beakers very frequently in this particular lab section, but anytime you would do something called a titration, odds are you'll probably be using flasks for that. It really just depends on the situation as to whether we use a beaker or a flask. Either way, they're great for measuring volume and the like. So just want to give you an opportunity to see those. We have a couple of other things in here we want to look at as well. We have some pieces of glass that are used on surfaces like this. If we have any materials that are hot, that prevents the heat from transferring directly to the surface here, which might be relatively cool, and then you end up with cracks in your glassware. So always good to use one of these if you are dealing with hot pieces of glassware. In addition to that, down here below, we have what are known as graduated cylinders. We don't have very many in this particular drawer, just a couple of 10 milliliter graduated cylinders. But these are used to fairly accurately measure the volume of a liquid. So odds are we'll be utilizing graduated cylinders quite a bit in order to measure volume. It's not the most accurate way to measure volume, but in a pinch, these actually work quite well and are fairly accurate for the most part, especially for what we will be doing in here. In addition to that, you may find in your lab drawer a large graduated cylinder, which just happens to be in the wrong drawer. I'll have to let my students know that they need to put these in the correct drawers. But you see one here that measures up to 50 milliliters. You notice the increments here as well. We'll talk more about those increments when we start talking about measurement and precision and accuracy in the next lab that we'll be taking a look at here in just a little bit. All right, in addition to that, you may find some test tubes, which are used to kind of mix small amounts of material. You see a reaction occur down towards the bottom there. We have a test tube rack, which is where we will place our test tubes if we need some place to put them. You also have a scoop that will probably be found in your lab area, as well as a stir rod. I know these aren't found directly in the lab drawers at the University of Cincinnati. You'll have to ask for one of these, or I believe there's like a common station where you'd find a variety of the different lab utensils that you might need. And we also have a pair of forceps in here, which would be used to grab certain materials. I don't recommend these for beakers or glassware because sometimes these things can slip and they don't hold things very well. So ideally we wouldn't use these for glassware, but for other things that we may use in lab. In addition to that, another test tube rack here, possibly wire brush. You may find some funnels that are in here that you may use in order to do maybe a filtration. We'll put a piece of filter paper in here and allow for filtration to occur. In addition to that, you may find a mortar and pestle in there, which you can use to grind up certain materials. And then lastly, the one thing I did want to show you, which we may use, again, not quite sure what the labs are going to look like this particular semester, but this is a volumetric flask. So this is a little bit different than the Erlenmeyer flask that we looked at previously. This actually accurately measures only one volume. Don't know if you can see the line up there at the top, but this specifically measures a certain volume. And what's really nice is it's very, very accurate. So if I want to make, let's say, a specific concentration of a solution, but specifically 100 milliliters of it, I would use this piece of glassware as it's the most accurate piece of glassware that we're going to be looking at in order to measure volume. Another one that's also quite accurate, which is actually already out at the lab station, you may have seen it over here, is this glass pipette. Glass pipettes are really good for measuring small amounts of volume accurately. So you see this measures up to about 10 milliliters here. In order to use this, we just simply add this to the top of the pipette, and then you're just simply going to rotate. There's a little dial back here that you can rotate, and what that does is that'll suck up the liquid, and then when you're ready to release the liquid into a beaker or an Erlenmeyer flask or a test tube, you just simply press the top part down here and it releases all of the liquid into the receptacle that you were looking at. So just wanted to give you a little bit of an introduction to some of the pieces of glassware that you might be looking at in lab. I would definitely make sure to keep in mind which ones measure things accurately versus which things are more or less just vessels that we hold materials in and react things in. So hopefully you enjoyed this brief introduction, and we will see you in another video very, very soon.